Before we begin, do subscribe to Farm Logic if you value historically tested farming methods, soil systems that work without machines, and agricultural knowledge built under real survival conditions. This channel exists to recover practical techniques ancient farmers depended on, and, well, the method you're about to learn was used precisely because it worked fast when land could not wait. Hard, compacted clay soil has always been a problem for farmers. It seals itself against water, suffocates roots, and honestly turns into brick when dry. Modern solutions rely on heavy machinery, gypsum, or, years of organic amendment. Ancient farmers did not have those luxuries. Yet they routinely softened hard clay fields in a matter of days, using a biological process that, I must say, modern agriculture has largely forgotten. Now, the trick was not digging deeper, It was fermenting the soil surface to force clay to unlock itself, really. Why, ancient farmers understood clay better than modern soil science, honestly. Clay is not dead material, not at all. It is electrically active, tightly packed, and highly responsive to water and biology, you see. Ancient farmers noticed, that clay soils changed dramatically after floods, manure piles, and soaked organic waste sat on them. They figured out, really, that biology, not force, was the key. Instead of breaking clay mechanically, they used fermentation to trigger rapid chemical and biological reactions that separated clay particles and reopened pore space. And this was not just guesswork. It was a repeatable practice, you see, used in parts of East Asia, the Middle East, and pre-industrial Europe. So, what fermentation does to clay at a molecular level is actually pretty fascinating. Normally, clay particles bind together tightly, you see, and that's mostly because of their electrical charges and the absence of, organic buffers. But when you introduce fermented organic matter, suddenly acids, enzymes, and a flurry of microbial activity flood right onto the soil surface. Now, these compounds get to work neutralizing those binding charges, causing the clay plates to swell and, create these tiny microgaps. That's what lets water and air finally slip in where they couldn't before. Meanwhile, there's this explosive growth of microbes, and they generate gases and organic acids that physically sort of push those clay particles apart even further. This combination rapidly loosens soil structure without turning it over. The result is clay that shifts from sealed and hostile to open and workable in less than a day under the right conditions. What the clay ferment mixture consisted of historically? Well, ancient farmers just used whatever fermented material they had on hand. Common sources included things like soaked grain mash, diluted animal manure that had started fermenting, sour whey, fermented plant teas, and even clay-soaked compost water. The real key was active fermentation, not just the raw material itself. The mixture needed to be biologically alive, acidic, and wet enough to soak right into the soil pores. These days, a practical modern version can be made using water, fresh manure or compost, and a sugar source like molasses or crushed grain to speed up fermentation. You just let the mixture sit for, 12 to 24 hours until it smells sour and active, but not putrid. So, here's how the 24-hour soil transformation actually worked. You know, ancient farmers didn't till before applying the ferment. They just applied it directly onto hard soil. The liquid soaked into cracks, seams and surface pores. And within just a few hours, microbial activity really intensified. By the next day, the soil surface softened noticeably. Water infiltration improved, and, roots could penetrate where they previously stalled. This was not permanent improvement, but it created a critical window where crops could be planted or, organic matter added deeper. Modern growers can test this by applying fermented compost tea or manure tea to a compacted clay patch and observing texture change after one full day. You know, why moisture timing mattered more than quantity is a bit of country wisdom passed down over the years. It's not always about how much water you use, but, when you use it, that truly makes the difference. This trick worked best when clay was dry, but not baked solid. Slightly dry clay, you see, absorbs liquid aggressively, almost like it's thirsty for it. Ancient farmers, clever folks they were, timed applications before rain or irrigation to extend the effect deeper. It was all about making the most of nature's rhythms, really. Now, too much water without fermentation simply caused sealing again, you see. The ferment, though, changed how clay interacted with water, stopping that immediate recompaction. So, a practical step is to water lightly before application. If your soil is bone dry, then, apply the ferment evenly and allow it to soak undisturbed. This is how ancient farmers locked in the improvement, really making those changes last. The ferment alone opened the soil. To keep it open, farmers immediately followed with organic cover. Straw, chopped plants, leaves or living ground cover were applied to protect the softened structure. Roots were planted while the soil was receptive. Once roots penetrated, they maintained channels long after fermentation ended. Right. So, modern application should follow the same sequence, really. Apply the ferment, wait 12 to 24 hours, then plant or cover immediately and, do your best to avoid compaction. Now, you might wonder why this method avoided deep digging. You see, digging clay actually destroys aggregates, and honestly, it just accelerates recompaction. That's why ancient farmers, they avoided this. They worked from the surface downward, letting biology pull improvement deeper. This preserved soil layers and prevented erosion, especially on terraces and slopes. For modern growers, this means, resisting rototillers and focusing on surface treatments that invite biological restructuring. Now then, where this trick still appears today, is quite interesting. Variations of this method survive in Korean natural farming, traditional Chinese wet-dry field preparation, and, well, indigenous compost teas all around the world. In each case, fermentation comes before planting on difficult soils, you see. Modern soil science now confirms what those ancient farmers noticed. Microbial metabolites and organic acids, they alter clay chemistry rather quickly when the conditions are just right. Well, what this teaches about soil repair is really quite important. You see, understanding how the land heals itself helps us, work alongside nature rather than against it. It's about patience, observation, and honestly respecting the ground beneath our feet. Clay isn't broken, It's just, misunderstood. If you try to force it, you only end up compacting it even more. But here's the thing. Biology, that's what really unlocks it. This little trick shows that repairing soil doesn't always have to take ages or require heavy machinery. With the right bit of biological pressure, clay can respond pretty quickly. For survivalists, gardeners, and small-scale farmers working on marginal land, knowing this can honestly mean the difference between planting now or missing out on a whole season. If this sort of historically grounded practical soil knowledge is important to you, go ahead and subscribe to Farm Logic. Share this guide with other growers facing tough ground. And, let's bring these tried and true ancient techniques back into use where they're still needed.